Okay, welcome back. We're on page 346 talking about why I should wash my incoming data through the setters. And the answer is, I do not want to bypass input validation, that secondary input validation, because I don't trust programmers. Programmers are going to make a mistake. They're going to type in a -12 here, and you'll never be able to figure out what's going on. So don't bypass secondary input validation in constructors. By the way, their example on page 346 doesn't do this, so I don't like their example. On the other hand, I should cut the author of the book a little bit of slack, because in order to do it the correct way, you would have to introduce this whole concept of inheritance, which we're not ready to do until a couple more chapters to go. So just leave these things as warnings and just say, hey man, if you ever override this, you could cause trouble. Okay, whatever, dude. Moving on. All right. So how do I call a constructor? I want to call a constructor. Well, from inside the Chapter 6 class, the only way to call the constructor is with new. Okay? There actually is a way that you can call a constructor inside here. Normally what would happen is one constructor would call another, and there's a whole thing about constructor, inheritance, and how, it calls this one first and then second that one, also other stuff that we'll talk about in some other chapter. But basically the answer to the question is, how do you call a constructor? Well, from here, from the outside, it's just the new operator. So this one called the default constructor, and this one called the parameterized. Ooh, isn't that a cool term? The parameterized constructor. Okay. So the last rule on constructors, let's go through the rules one more time. So I'm building a constructor, all right? So the first rule is the constructor must be named the same as the class. Okay, cool. They do not have a return type, which is extraordinarily rare. Every other method in the entire system has a return type except for the constructors. So you should be able to spot line 20 and line 25 because it does not have a constructor. Okay? Hey, what happens if I put one in there? Doggone it. No, don't do that. It's going to annoy you. And then you can have more than one as long as the signatures match. Trust me, we'll get back to that. And then the fourth one says, if I was to create this one on line 25, okay, it will take away this default one. Now what that means is, when we were doing this at the very beginning, like up in here, we did not have any code that we wrote for this constructor. And the reason is it wrote one for us. It gave us one out of the box. So even though we couldn't see it, it was there. But as soon as you create, ooh, what is that? Oh, as soon as you create a parameterized constructor, the default constructor goes away. All right? So if you build this, you're going to have to probably go back and build that, unless you go here and get rid of all the ones that don't have parameters. I have 3 of them that don't have parameters and 1 of them that does. Okay? Making sense? If you create a constructor on your own, the store-bought one goes away. Okay, good. All right, so let's talk about this. So we kind of sort of mentioned that back in this thing that yeah, you can do this, right? That kind of sort of makes sense because I'm using a constructor, passing it a string constant, and it's being stored. I mean, most people don't because it just looks ugly, right? So anyway, on page 350 they talk about string constructors, and just kind of gloss over that section and move on. It's not important. Okay, on page 358 they talk about passing objects as arguments. Well, so instead of passing something like a literal, right? This is literal. This is a literal. What if I want to pass an object? What if I want to pass a rectangle to a rectangle or something like that? Okay. Is that something we could do? Yeah, we could do that. In fact, one of the things we can do, this sounds a little weird. Let's create another another constructor. Okay, we'll do public rectangle, and it takes as an argument another rectangle. In other words, like I want to give it like a starting location, right? Like, I don't know, like a template or something. Rectangle, I don't know, R. And then, now, in this particular case, since something is already a rectangle, it's already a rectangle, which means it has already gone through some sort of secondary input validation, I would allow you to say PFV length is equal to R dot get length. I'll let you do that. Because there's a reasonable assumption that since it's already a rectangle, come on, right? If it was already a rectangle, then the sanity checking has already occurred. So let's go back to here. And so I'm going to take this bedroom and I'm going to make it like so I'm going to do rectangle. I can't spell rectangle to save my life. This will be master bedroom. Is equal to new rectangle. Dang, I can't spell that. Bedroom. So all I'm doing is just passing, I'm just passing an object. There's nothing special about this other than the fact that I misspelled it. Okay, there's nothing special here, right? And then I could do some extra things to the master bedroom, change its size or whatever, some other property. Okay, kind of makes sense. So again, passing arguments on page 358. Whoopee! Let's move on. So, overloading methods and constructors, page 370. All right, now we're back to this thing called the signature. Yes, I can have two methods. It doesn't matter. I can have two methods of the same name. Okay? It's perfectly okay as long as the arguments are different. Okay. So for example, I don't know, I'm kind of running out of, every example we have is just using these constructors. But let's go down here to this calc area thing. I'm going to create me a second calc area. And this will be a generic one. In other words, I don't want to have, I want to be able to pass length and width. Now, it's not going to set them or anything. I'm just using it as a calculator. Okay? So, that'd be double length, double width. And since this really isn't part of the data, okay, I'm just using this as a calculator, and I'm not setting anything. I'm not going to do any secondary input validation because there's no harm. In all the rest of the cases, I could have done harm, but not here, okay? I can't do any harm here because I'm not actually changing anything in the class. Okay. So, why do I have a red squiggly? Oh, because I haven't done anything yet. I'm just going to cheat and do return length times width. Okay, cool. All right, so these are two different methods, but they happen to have the same name. All right. All right, so you ready for the rules? Of course you are, because you got your pencil and paper ready, and every time you hear me say rules, you grab your pencil and paper, don't you? Okay, good. A method signature is made up of the following. The method name, in this case, calc area, the number, the type, and the order, number, type, and order of arguments. So this on line 65 has no arguments. On line 77, I have two arguments. Now, if I can have another one, let's do another one. I'm just going to copy and paste because I don't like typing. I'm going to make one of them an integer. Okay? They're different now because this one has a double, so it's the number of arguments, the type of arguments, and the order of the arguments. Let me show you what I mean by the order of the arguments. Let's do another one. So this time I'm going to make this one a double and make the second one an integer. Okay, so it's the number, the type, and the order. Now notice that the method signature has nothing to do with the return type. Nothing at all. So for example, I cannot go here and like change this to an int. Okay? I get red squigglies saying, hey man, it's already defined. Because the return type is not part of the method signature. Okay? And it should be fairly obvious that the variable names don't have anything to do with it. I mean, the variable names, come on. I can't tell the difference between length and length 1 or length 2, right? It's the order in which they appear in their data types, okay? Not the name of the variable. Okay, the scope of instance fields. An instance field is, one that got created during the instantiation. Ooh, okay. On page 378. So when private, which is most of the time, they can only be seen from inside the curly braces for the class. Okay, so this got created under this, right, under the class and before, right, before all the methods and constructors and stuff. So anyone inside this class can see this. That's kind of makes sense. But other people from the outside cannot see any of the things that are, that are marked private. Cool? All right. So on page 380, they talk about packages and import statements. Now, we have a thing here called a package. So this package name, in fact, if you go to the very top, it says package is chapter 6. So package is, by the way, the name of the package gets created when you first create the first class, okay? And it takes the class name and makes it lowercase. So if your very first class was called Kumquat, then your package name is going to be called Kumquat. Okay, kind of makes sense? Cool. And notice that the package names is lowercase. Since both of these guys share the same package, Rectangle has the package of chapter 6, and the chapter 6 class has a package of chapter 6, then these two guys can see each other without too much trouble. Now, it should be fairly obvious that inside here, the way I reach over from inside chapter to get to rectangle, okay, chapter 6 got created first, so to speak, and the way I'm able to reach over and grab a rectangle, I have to do this thing, right? I have to do one of these new guys. But how can rectangle reach back and talk to chapter 6? It can't. This is like in other words, who started the conversation? Okay, if chapter 6 started the conversation, then that's the only way you're going to communicate. Yes, you could pass data back and forth between the two classes with getters and sitters, right? Okay, getters, sitters, and methods. But Rectangle can't initiate the conversation back. Say, hey man, talk to me about what you got over there on chapter 6. And no, I can't do that. Okay. Now, import statements. I don't actually have one. I guess I could create. Yeah, I do. Since I created the scanner, if you go back up to here, it imported this guy for us. Okay. So the import guy is to try to get other types of packages to show up in our application. And so instead of just cluttering your mind with absolutely everything, you have to manually go in and like line 8 and add something. Okay. So here's a list of some of the common packages that you can spot. I mean, there's a bunch of these guys, and it's a pretty good list, and we've used some of these. We've IO, and we've used a bunch of other things. And we're coming up on the 15-minute mark, so you know how this works.